Hello, my name is Mary Getty, and welcome to my video on sublimation. So sublimation is uncommon. It's the direct transition of a substance from the solid phase to the gaseous phase without going through a liquid phase. It occurs when a solid compound's vapor pressure is equal to its applied pressure, and we'll talk about why this happens on the next slide. Because this is so rare, it is an excellent purification method where the volatile substance is contaminated with non-volatile impurity. In this instance, the impure solid would be heated in the bottom of a vessel close to a cold surface called a cold finger, and as the volatile substance sublimes, is deposited on the surface of the cold finger where it can later be recovered, and thus you can separate the non-volatile substance left behind from it very easily. But this is also known as green chemistry because there's no solvents involved and nothing goes to waste. So how it works. As stated on the last slide, sublimation is uncommon because it happens when the solid compound's vapor pressure equals its applied pressure. Compounds that are capable of sublimation tend to have weak intermolecular forces in the solid state, like compounds with symmetrical or spherical structures, like shown in figure 6.28. Of solids with appreciable vapor pressures at room temperature, many still require rather high temperatures to actively sublime. If the solids are heated prior to their sublimation points under atmospheric pressure, some will char and decompose during the process. For this reason, it's very common to perform sublimation under a reduced pressure, cold vacuum sublimation. However, here we'll talk about sublimation under atmospheric pressures. So first, you would go and determine the empty mass of the Petri dish, and then spread a contaminated solid in a thin layer on top of a bottom Petri dish. You may need to crush the substance with a mortar and pestle if necessary to ensure that it is actually nice and evenly coated. It's also vital that the substance is dry. If the substance is wet with solvent, condensation may form on the top Petri dish during the sublimation. In the beginning stages of the sublimation, small amounts of condensation can be wiped off the top Petri dish with a paper towel. But too much condensation, if left behind, may wash crystals off from the top dish. Next, you would cover the bottom Petri dish with the top and place on a wire mesh on a hot plate in the fume hood to set to a temperature slightly below the sublimation point. The wire mesh helps dissipate the heat evenly throughout the dish and minimize charring. Next, a 600 milliliter beaker filled with ice water should be placed on top, and after that, the sample will start to sublime and collect on the upper Petri dish. Monitor the sublimation as compounds may char during this process. So if it starts to blacken, turn down the heat so this doesn't continue. Go ahead and continue the sublimation until it appears as if little or no solid remains on the bottom. Note that it is common for crystals to also grow on the sides of the bottom dish. Continue until nothing remains on the bottom. Then carefully remove the Petri dish from the hot plate with the hand protector. If you jostle the dishes, it may cause sublimated crystals to fall off the top Petri dish, and then it'll be much harder to recover them. Though, note as for safety reasons, I'll make sure to allow the two dishes to cool intact on a ceramic tile in the fume hood. Do not remove the top Petri dish right away, or noxious fumes may escape. The crystals on the top Petri dish are purified and should be retained, and their mass then determined. Sometimes material on the bottom dish may also be saved if it appears crystalline, like if it fell off, and then the appearance would help indicate that it did go through the sublimation process. Though this should only be done if it doesn't appear contaminated with char or other substances. And now for the reduced pressure, so in a vacuum sublimation state, which is the more common version. Similarly, you would go and spread the dry contaminated solid on a thin layer of the sublimation apparatus, making sure that everything's still dry so that crystals don't wash off the cold finger, which is what the crystals will collect on instead of the top Petri dish plate. You should secure the apparatus to a ring stand to support, and then if it's smaller scale, you may need to support with a platform. Then with a syringe, lightly grease the joint that connects the two pieces of glassware at the end not in contact with the sample. Insert the top piece of the sublimation apparatus, called the cold finger, and twist the two pieces of glassware together to evenly spread the grease in the joint. When using a round glass, the grease should cause the bottom half of the joint to become transparent all the way around. If the entire joint becomes transparent, too much grease has been used and some should be wiped off. Use thick-walled rubber tubing to connect the apparatus to a vacuum source, like a vacuum line or water aspirator, and then apply the vacuum. To prepare the cold finger, you may need to do one of a couple things. If the cold finger has a condenser, connect water hoses such that the lower arm connects to the water spigot and the upper arm drains to the sink, and then begin circulating the water through the condenser. If the cold finger is an empty tube, fill the cold finger to the brim with ice, then pour in enough water to fill the finger about 3/4 of the way. The cold finger could also be filled with dry ice and acetone. Be sure to apply the vacuum before cooling the finger to prevent water condensation from forming, which again could wash crystals off. Then it's time to heat the substance. Note that you want to do this with a heat gun or Bunsen burner, beginning slowly with a back and forth motion and low heat. It's not recommended to use a sand bath or a heating mantle, as they can often be too slow and only cause direct heat to the bottom of the apparatus, not the sides. Increase the rate of heating if the sublimation does not begin within a few minutes. Solids should begin to deposit on the cold finger and generally will also happen on the outside of the glassware. Solid can be coaxed away from the outside of the glassware towards the cold finger by waving the heat gun or burner periodically up the sides of the glass. Continue the sublimation until all the volatile substance is transferred from the bottom piece of glassware to the cold finger. If the compound begins to darken, decrease the rate of heating to prevent decomposition. Then remove the coolant from the cold finger. If a condenser was used, turn off the circulating water and carefully remove the water hoses from the apparatus. If an ice water coolant was used, scoop out the ice if possible and remove the water with a pipette. Allow the system to cool or to room temperature, and then delicately reinstate the air pressure to the apparatus. An abrupt opening of the system will cause the air to violently enter the apparatus and may cause crystals to dislodge from the cold finger. Delicately remove the empty cold finger from the apparatus and scrape off the sublimed crystals onto a watch glass. Or alternatively, you could rinse the crystals from the cold finger with a solvent through a funnel and then into a round bottom flask to later remove the solvent using a rotovap. Apologies for that. I hope you enjoyed this video. Thank you very much and have a nice day.